It's very important to the process of understanding Google Cloud and passing the certification exam that you go through the question and attempt answering it yourself first. So pause the video, work through the question. We'll catch up in just a little while and I'll show you how I do it. In this project scenario, you have a data processing pipeline that uses Cloud Dataproc to load data into BigQuery. A team of analysts works with the data using a business intelligence or BI tool running on Windows virtual machines or VMs in Compute Engine. The BI tool is in use 24 hours a day, 7 days a week, and will be used increasingly over the coming years. The BI tool communicates to BigQuery only. Cloud Dataproc nodes are the main part of the GCP cost of this application. You want to reduce the cost without affecting the performance. What should you do? That's a fairly large question. Let's break it down into the requirements and analyze those. One, the business intelligence tool is running on Windows, and it's very clear that it is compute VM dependent. We won't be able to move it into some kind of serverless option. The BI tool is in use 24/7 and is going to be increasingly used over the coming years. So we've got a good forecast for the entire year that all these VMs that we use for the BI tool is going to be utilized. It is not going to lie idle. We could work with that. Then the data processing pipeline that uses Cloud Dataproc to load data into BigQuery, that loading happens only occasionally. So Dataproc doesn't need to be running all the time, right? Since it's running only occasionally, we could bring up Dataproc and then probably shut it down later on. Cloud Dataproc nodes are the main part of the GCP cost of the application. So clearly this is an area we should optimize. Right? We have to bring down the cost of Cloud Dataproc that we are incurring right now. The goal is to reduce the cost. So anything like serverless or any kind of new development would add cost, and that would not be acceptable. We also have to reduce cost without affecting the performance, which means that, for example, using the BI tool, we can't allocate cheaper VMs with lower memory or lesser configuration, right? Those VMs will have to remain exactly the same. With those requirements understood, now let's look at each of the options. But before that, since committed use discount is a part of every option, let us just study that in the beginning. So committed use contract essentially give you a very steep discount, as high as 50 to 70%, depending on the kind of resources you use and how long you use it for. But the downside is that they will bill you whether you use a resource or not. So if you have a committed use contract for say 100 virtual machines, and if you use only 50, you're still going to be billed for all 100. Committed use discounts are very good when you have predictable resource needs. When you know well into the future that, hey, I'm going to be using this for 3 years, 4 years, or 1 year, then you can get into a committed use contract. And that will be either a 1 year or 3 year contract. So you need to have at least that much of a forecast. Having understood those, now let's look at the options. Option B suggests apply committed use discounts to the BI tool VMs and the Cloud Dataproc nodes. Create the Cloud Dataproc cluster when loading data and delete the cluster when no data is being loaded. Now, committing to a certain number of VMs for use with the BI tool is definitely an intelligent move, because we know we'll be using them throughout the year and it is going to be increasing in use over the years. So to get into a committed use contract will drastically drop the cost of those VMs. So that's definitely something we should do. However, committed use discount for the Cloud Dataproc nodes, that is unnecessary. It's wasteful because we'll be only using them occasionally. We'll anyway have to pay for them, but we won't be using them. And therefore, that's wasted. Also, in this suggestion, it is given that we get into a committed use contract for the Cloud Dataproc nodes, but then we keep creating and deleting VMs as and when we need. Now that's again wasteful, right? I mean, if you've anyway committed to it, you've got the discount, you might as well keep it running. In any case, just for the fact that we don't need the committed use contract for the Dataproc nodes, helps me easily eliminate option B. Option C suggests apply committed use discounts to the BI tool VMs and the Cloud Dataproc nodes. Now this is pretty much the same as the previous option. It is just not giving the extra option of bringing up the machine and taking it down. But the same thing applies, that in committing to use all these machines, you're going to be billed for it, and we'll be paying for VMs that we are not going to use, and that's wasteful. So option C is out too. Option D recommends that we apply committed use discounts to the BI tool VMs. So now it's saying apply only to the BI tool VMs, right? Not to the Dataproc VMs, which makes sense, of course, because that is the one that we have a good forecast on, right? Not the Dataproc ones. And therefore, that's a good approach to get a committed use discount on the BI tool VMs. However, this option does not optimize for the Dataproc VMs cost, which, as the question says, is one of the main components of the cost. So this gets us somewhere, but it's probably not the complete option. We'll eliminate D for now and continue looking. Option A suggests apply committed use discounts to the BI tool VMs and create the Cloud Dataproc cluster when loading data and delete the cluster when no data is being loaded. So this combines the best of both. We saw it was a great idea to get into a contract for the committed use discount for the BI tool VMs because we know that we are going to use it throughout the year and more. So that's definitely good. For the Cloud Dataproc cluster though, we know it's going to be occasional, right? So it allows us to only create those VMs when we want it, run the processing jobs, and then delete it immediately after, in which case we are only paying for that short period that we use the Dataproc cluster for. So this combines both cost reductions across Dataproc VMs and the BI tool VMs. In addition to that, though it is not mentioned, we could also use preemptible VMs with the Dataproc jobs, which means that we can further reduce cost. So all in all, option A covers all our requirements and will bring down the cost in the maximum way. Alright, now it's time for you to like, share, comment and subscribe. Go ahead, do that right now, because there's loads of great content coming up for learning Google Cloud and preparing for the certifications.